Hello children, the continuation of wave optics, in that diffraction. See, the phenomenon of bending of light around the corners and the encroachment of light within the geometrical shadow of the opaque obstacle, which is called diffraction, right? See, if you look clearly at the shadow caused by an opaque object, suppose, close to the region of the geometrical shadow you have taken, there are alternate dark and the bright regions, just like the interference, right? So this happens because of what we said, the diffraction. See, usually diffraction in general, the characteristics of the diffraction, which is exhibited by all types of waves, such as like sound waves, light waves, right? Since the wavelength of the light is much smaller than the dimensions of most obstacles, we do not usually encounter the diffraction effects in our day-to-day life, everyday life observations, right? See, with the help of the source and with the slits, like we have seen, we started with the single slit act as a new source from which light spreads out in Young's experiment, right? We have discussed about even before in Young's experiment also, they have noticed that the light spreads out from narrow holes like slits in this way and captured on the screen, right? It seems to turn around the corners and it enter the regions where we would expect a shadow, right? So these effects, which known as we said, that is the diffraction. So that can be properly actually understood using wave ideas. And after all, you are hardly surprised to hear the sound waves from someone which is talking around the corners, right? You may think, right? So when the double slit in Young's experiment is replaced by the single slit, that is a narrow slit, a broad pattern with the central bright region we have observed, right? On both sides there are alternate dark and bright regions we observed, the intensity becoming weaker away from the the center, right? See, we can understand by explaining the diffraction in this way. We'll see one by one, right? So these are all XY, which is the region, and the diffraction at a slit, and this is an obstacle. How the difference, right? Now we will see one by one the diffraction of light at a single slit, and you are seeing that if suppose first one we have taken as theta, which is equal to 0. If it is with the 0 degree angle at the central point on the screen, see the slit and light waves which encountered the plane wave with the help of converging on one place, that we got the bright fringe. But the angle theta, which is 0, so that all path differences are 0. And hence we can say that all the parts of the slits contribute in same phase, and it gives the maximum intensity at the point O. So through this experimental the observation you can understood that, and this indicates the intensity had the central maximum theta, which is equal to 0, right? So the wavelet from the single wavefront reach the center O on the screen in the same phase, and it interference like constructively, that is maximum, what we said, right? Because of the angle theta, which is equal to 0, the all path difference, or that's why it is 0. So all the part of the slits contribute in the same pace, right? So we got actually the maximum intensity at the point. So this is the reason for that behind the thing. And the next one is, if suppose the theta, which is equal to theta 1, little we have changed the angle. Now we have to divide the slits into two equal halves. That way you can see we have make an angle and we have to divide into the equal halves, and for each point there is a meter, right, which is there. So here in this case, the wavelet from the single wavefront diffract at an angle theta 1 such that the BN, check the BN, which created the lambda, a lambda at the point P1, and the pairs, see that a pair of the wave which is going 0 to 0, 6, 1, 7, 2, 8, 3, 9, like consecutively till 6, 12, it is interfere destructively with the phase difference lambda by 2. It is secondary minimum. So the first one is it got the bright fringes. The next it is getting little the intensity is decreases, right? See that. And the third case, by the third case you can understand more. If suppose we have taken theta which is equal to theta 2, what will happen to that? Suppose this much of angle which is created, and why they go on becoming weaker and weaker with increasing the number n, right? So now we consider that maybe the theta is equal to 3 lambda by 2a. We have taken the midway of between the two dark the fringes. So it divides the slits into 3 equal parts, right? So if we take the first 2/3 of the slits, the path difference between the two ends, which we can see that it is also interface the destructive with the path difference lambda by 2, and it gives secondary minimum, and it is also getting very less intensity, right? So the fourth case, theta which may be theta 1. Now see this. So in this case, the path difference, all the pairs of the waves you can see 0 to 8, see that check, and 1, 9, 2, 10, check the 2, 10, right, 3, 11, like these pairs which shows the interfere constructively with the path difference lambda. And also if you have seen the next pairs of that, it gives the destructive path. So maximum it reaches, and then it's a minima, like central maxima and minima, it is getting both together. By that way only we are getting the diffraction. Now the diffraction at various angles, how it will be, with this diagram we can see, right? So with the help of this various angles we can get the intensity distribution curve. See, first angle we have seen, second one is we got theta 1, then we have taken that one P1 dash and the P2. So these are all the angles which is get varied. So we plot suppose a graph for this intensity of the maximum and minima against the diffraction angle theta. We'll get the central maxima, that is it has a broad central maxima, and we will get the minimum of it is getting, and it has a secondary minimum of a decreasing intensity positions you have seen. What we explained with the different structures, right? Diffraction structures we have explained. So all together we are seeing through this the variation of intensity with the angle, if suppose with the single slit diffraction, right? So from this we can understand the central maximum is the brightest fringe. The diffraction, it is not visible after a few order of the diffraction, right? So now how the theory about we'll see the path difference from 0 to 12 between the Bn, and if suppose the theta is the angle of diffraction and d is the slit width, if suppose we have taken, then what it will be, Bn which is equal to d sine theta. See, through this we can calculate this path difference. For your convenience, I'm showing this previous the diagram. Suppose the secondary wavelength diffracted at an angle theta or focused at point P or P dash. If you drawn a perpendicular from that AB of the ray, then the path difference between the wavelet we can take that P which is equal to BP minus AP. So Bn, that is only we said that is AB sin theta. So that only it came d sin theta. Got it? How the d sin theta came? So Bn which is equal to d sin theta. To establish the condition for the secondary minima, the slit which are divided into 2, 4, 6 like equal parts corresponding to the wavelets from the successive regions of interfere with the path difference of lambda by 2, right? So we will get the positions of minima, and the positions of minima which is from order nth secondary minimum, that is the slit which can be divided into 2 equal parts we said. Is it right when we are explaining? So lambda which is equal to d sin theta we have taken, and the positions of minima we have divided the slits into 2 halves. So the path difference between the wavelets from any 2 corresponding points we have taken, that is nothing but lambda by 2. So the wavelets gets added up, destructively to produce the minima, right? So that d sine theta which is equal to lambda, or d sine theta 1 which is equal to lambda for the theta 1 case. So we have taken for that a number of cases. We will get, so theta n which is equal to n lambda by d. So that n which is equal to, we have taken 1, 2, 3 till n number of cases we have taken. So the direction of various minima we will also see. So to establish the condition of the secondary minima, the slits which are divided into 3, 5, 7 like in the odd. So we will get that d sine theta which is equal to 2n plus 1. So d sine theta 1 which is equal to 3 lambda by 2, 5 lambda by 2, like that it will come. So to till n, so theta if suppose which is equal to n means, so 2n plus 1 lambda by 2. Got it? So here 2n plus 1 lambda by 2d, because of theta n which is maybe a very small, we have taken that the 2d, and n which is equal to 1, 2, 3 till n. Got it? So this is for the position of minima and the position of secondary minima also, right? And in the next case we said first secondary maxima and secondary maxima also, right? So nth secondary maxima. So this theory part will give the calculation for the path difference, that is bn which is equal to d sine theta, how we got it, and the position of minima, that is lambda which is equal to d sine theta 1 we have taken. The theta which is getting varied, the path difference between the wavelet which is getting varied, corresponding to, if suppose we are divided into 2 slits, so lambda by 2 we have taken. So that only destructively we are getting minima and constructively we got the maxima. So both the case we explained here. Next, the width of central maximum. How the central maximum, width of central maximum with the help of the angular width of the central maximum, which is the angular width of central maximum, which is nothing but first what? That is the angular separation between the direction of the first minima on the two sides of the central minima we can take, right? So the direction of the first minima on either side of central maximum, which are given by what? Theta which is equal to lambda by d, right? So the angular width of central maxima we can say 2 theta which is equal to 2 lambda by d. So what is the linear width of the central maxima? The linear width of the central maxima, that we can say if d, the capital D we have taken the length, that is the distance of the screen from the single slit, then the value which we can get 2d lambda by small d. That is because of 2 theta which is equal to radian, is it right? From that we know, from 11th we have studied 2 radian which is equal to arc by radius. So we are telling arc by radius it will come, that is beta naught by capital D will come. So that 2 theta which is equal to beta naught by capital D we can say. So that only beta naught which is equal to capital D into 2 theta. From that only we got 2 capital D lambda by small d.